Hello viewers, welcome to my channel. If you haven't yet subscribed to my channel, do subscribe it and press the bell icon near the subscribe button so that you get the notifications of my latest videos. And do not forget to like and share. In today's video, we'll be learning about the chapter 10 of NCERT and the chapter 1 of physics. That is light, reflection and refraction. And in today's video we'll be learning particularly about refraction. What is refraction, the definition, and then refraction in different media, and then we'll be going for the laws of refraction of light. Okay, so let's start the video. See, refraction. Now you see that when light travels from one medium to another medium, it has a tendency to bend. It has a tendency to bend. See, when you see that light is traveling from one medium to another medium, its direction changes. This is air. Consider this to be air. This medium is air. Okay. Medium in the sense anything through which light can travel. That is anything through which light can travel. This is air. Okay. Consider this to be air. This medium is air. And this medium is your glass. Medium 1 air, medium 2 glass. When light travels from one medium to another medium, its direction changes. See, the direction changes, and this phenomenon is known as refraction. So that is what I've defined over here. The phenomenon of bending of light at the interface. Interface means this part. Between, whatever is there between any two media, that is known as interface, where light tends to bend. That is known as interface. The phenomenon of bending of light at the interface of two media when it passes from one transparent medium to another transparent medium. The direction of propagation of light changes. You see, light propagates in different directions in different media. Now, why does this happen? This happens because the speed of light in different media changes. The speed of light changes in different media. Okay. Now, let me tell you what is a rarer medium and what is a denser medium. Okay. Now, a medium means anything through which light can travel. Anything through which light can travel is medium. Now, let me tell you what is a rarer medium and what is a denser medium. Now, rarer medium. Okay. Rarer medium. Rarer medium and denser medium. Okay. Rarer medium means any medium through which the speed of light is faster. The speed of light is faster in vacuum. The speed of light is faster in air. Such media are known as rarer medium. The medium in which the speed of light is faster. Okay. Now, denser medium. Denser. You see, denser. Now, this kind of medium. Okay, how would you define it? Exactly opposite. Any medium in which the speed of light is slower. Okay. In rarer medium, the speed of light is faster. In denser medium, the speed of light is slower. And what example can I give for denser medium? Glass. Glass is a denser medium. Water is a denser medium. Okay. So this is rarer medium and denser medium. Over here, can you guess which is the rarer medium and which is the denser medium? Air is the rarer medium. Okay. And glass is the denser medium. Already I have given in the examples itself. You can see it. Air is the rarer medium and glass is the denser medium. Okay, now you know what is normal, right? Normal means the perpendicular line over here. This is normal. And what is this I and what is this R over here? This is the incident ray. The ray that is incidenting on this part. Okay. The ray that incidents in this and in this interface is known as incident ray. I have used the letter I for that to express incident ray. And over here, this ray which is getting refracted, the ray which is getting refracted is the refracted ray. Refracted ray. And here I have used the letter R. Okay. And this part, this is the normal. The perpendicular line is known as the normal. The angle formed between the normal N and N dash, okay. The angle formed between the normal and the incident ray is known as the angle of incidence. And here the angle formed between the normal and the refracted ray, angle of refraction, okay. Angle of incidence and angle of refraction. Now what happens is when if light travels from rarer medium, air is a rarer medium, right, and glass is the denser medium, okay. Denser medium, rarer medium, denser medium, glass is the denser medium. If light travels from a rarer medium to a denser medium, light has a tendency to bend towards the normal, okay. You see, this is the incident ray. It travels in air. The ray travels in air, and when it comes to a denser medium, when it comes to the glass, it bends towards the normal. You see, it is bending towards the normal. Now same if you take it in the opposite manner, if light travels from a denser medium to a rarer medium, okay, I'll draw it over here. If light travels from a denser medium, suppose now this is glass, okay, this is glass and this is air. This is the normal, okay, normal N dash, and this is the glass. This is the incident ray, angle of incidence. What happens when light travels from denser medium to rarer medium? It moves away from the normal refracted ray, okay. Now when you compare the angles, you see here in the denser medium, angle of incidence is lesser than this angle of refraction. Over here when you see, this is the air, the rarer medium. Here again the angle of refraction is less than angle of incidence. Here the angle of refraction is more than angle of incidence, okay. Sometimes questions can be asked based on this also. Okay, now I'll be teaching you about the laws of refraction. About refractive index, I do not want to mix it over here. I do not want to mix refractive index over here because I don't want you to get confused. So now I'll be telling you about the laws of refraction, okay. Alright, now the laws of refraction laws, okay. The laws of refraction. Two laws of refraction. First is the incident ray. The ray which incident I showed you, right? The ray which incidented N dash, this incident ray, okay. The incident ray, then the refracted ray. This is a refracted ray, okay. Sorry, the refracted ray, then the normal, okay, and the normal, this is the normal, the perpendicular line, the normal the interface of two, write in spelling itself, two transparent media it is perpendicular, this normal is perpendicular to the interface, the normal is perpendicular to the interface of two transparent media. This is medium 1 and this is medium 2. The normal is perpendicular to the interface of two transparent media, to the interface. This is known as the interface, okay? Interface. Okay. So, the normal to the interface of two transparent media at the point of incidence. This is the point of incidence. This point is the point of incidence. All lie in the same plane. This is the first law. This is the first law of refraction. Okay, this is the first law of refraction. The incident ray, this is the incident ray. Okay, the refracted ray, this is the refracted ray, and the normal, this is the normal to which it is normal. It is normal to the interface of two transparent media at the point of incidence where it incidents. Okay, where it is incidenting, where the ray is striking. This part is the point of incidence. Okay, so the incident ray, the refracted ray, the normal to the interface of two transparent media at the point of incidence, these all lie in the same plane. Okay, incident ray, refracted ray, normal to the interface of two transparent media at the point of incidence, they all lie in the same plane. This was the first law of refraction. Okay, now the second law of refraction is also known as the Snell's law of refraction. Okay, not the first one, only the second one. The second law of refraction is also known as Snell's law of refraction. Okay, that is the second law of refraction, which is also known as Snell's law. Snell's law of refraction. Snell's law of refraction. Snell's law of refraction, or the second law of refraction. What this says is the ratio of the ratio of the angle of incidence, sorry, the ratio of sine of, very sorry, the ratio of the sine of angle of incidence to the sine of angle of refraction is a constant. It is a constant for, there is a condition. The ratio is constant for something. The condition is the light of a given color, then for light of a given color, and for the given pair of media. Okay, for the light of given color and for given pair of media. Okay, but this has a condition, because this is true for angle. This is true for angle. True for angle of incidence. There's a condition that angle of incidence should be greater than 0. Okay, the angle of incidence should be greater than 0 but lesser than 90 degrees. This condition should be followed. Okay, right. Now Snell's law of refraction, or the second law of refraction, says that the ratio of sine of angle of incidence. Which is the sine of angle of incidence? Suppose this is n dash, your normal. This is the incident ray. Okay, this is the incident ray and this is the refracted ray, and here this is the angle of incidence and this is the angle of refraction. Okay, the ratio of this angle, the sine of this angle and the sine of this angle is a constant. Okay, it is a constant. The ratio of sine of angle of incidence, the sine of this angle. Okay, when you compare the ratio of this angle, the sine of this angle and the sine of this angle, it is a constant. But there's a condition that the color of the light, it is constant for the light of a given color. For any given color it is constant, and for given pair of media it is constant. Now say I take angle of incidence as I and angle of refraction as R, then how would I express this in the form, in a different form? If I want to express this, I write it as sine of angle of incidence. Okay, sine of angle of incidence to the sine of angle of refraction is a constant. Okay, constant. Write it fully, constant. Since I don't have place over here, I've written in this way. After writing this law, do write this. Okay, do not forget to write this. You have to mention this. Okay, the Snell's law of refraction says that the ratio of sine of angle of incidence to the sine of angle of refraction is a constant for given color and for the given pair of media. But this is true when it is true when angle of incidence is greater than 0 but less than 90 degree. Okay, so that's it for today. In the upcoming videos I'll be teaching you more about refractive index, and I'll teach you the whole chapter, this whole light chapter, because I've been getting so much of requests like, sister, please make a video on this chapter, and there was more demand on this topic, refraction, so I decided to make this video first. Goodbye, take care, and revise every day.